Alrighty, hi Zach, welcome to lesson number 93, and this lesson is going to start on page 388 in your book if you're following along, and we're going to go over something that you probably already know, or you can figure it out if you think about it, and that is the products of rational expressions and then the quotients of rational expressions. So I think you know how to do that because products, remember, are the answers that you get when you multiply. A rational expression is just like a fraction. Remember, it has the word ratio in it. And then quotients are the answers that you get when you divide. Quotients of rational expressions. Of course, you're going to be doing a little bit more than 1/4 times 2/3, right? You're going to be doing very complex algebraic equations, but you're still going to be multiplying them, dividing them, and the rules turn out to be the same as just as if you were doing one of those simple equations. So that's why I say you probably already know it if you think about it. All right, first, let's get started by looking at this comic. Here's a teacher in a class, and she's saying, okay, let's start the exam. Stinking caps on, everyone. Stinking caps on. Have you ever heard a teacher say, thinking caps on, put your thinking caps on? Well, the skunks put their stinking caps on before they start their lessons or exams. Okay, here we go. Products of rational expressions. So what does that mean? That means we're going to take two fractions. Oops, I just deleted everything accidentally. We're going to take two fractions and we're going to multiply them. Now, remember the rules when you multiply fractions, and it's not like adding or subtracting them. Multiplying them is super easy because you just multiply the numerator times the numerator and you get a new numerator, which is just the product of the multiplication, and then you multiply straight across the bottom denominator. So 4 times 2 is 8. So if you were multiplying 1/4 times 1/2, obviously you get 1/8. So it's the same type of thing as when you're multiplying something really complicated like this. You're just going to multiply straight across. So like this times this, that's going to be your new numerator. And then this times this, that's going to be your new denominator. So let's do it just to make sure that we understand how, okay? So if we're multiplying 4x times 3xa, that's going to be easy because we just multiply, let's multiply these numbers first, the 3 and the 4. The 3 and the 4, you're going to get 12. The x times the x, you're going to get x squared. And then there's just one a, so you put the a right there. Now, when you multiply the denominators, you get 5 times y, which is just 5y. And so this is it. That's all there is to it. That is the answer to that problem. All right. So, see, you already know how to do it. Makes sense now, of course, right? Makes sense. All right. Let's jump into example 93.1, and I'm keeping you happy here with some pictures of SpongeBob because he is the happiest sponge in the world. Hi, Zach. You want to say hi to future Zach? Come on. Okay, you're making faces at me. You don't want to, obviously. You are more like Squidward in this picture and not SpongeBob, but that's okay. I'll be the SpongeBob and just throw flowers at you. Here we go. So we have this fraction. Here's the numerator. Here's the denominator. We're going to multiply it by this fraction. Here's the numerator. Here's the denominator. Now, this one's a little bit more complicated than the last one. And of course, you would do it in the same way. The problem is that if you multiply, like if you put parentheses around this and parentheses around this, the book points out that what you get for a new numerator is going to be super complicated. You would have to FOIL that out, right? First, outside, inside, last. You can't just multiply them together. So it would be first, would be x fourth minus 20. I'm not doing this in my head. I'm just putting what the book says the answer is going to be. Minus 25x squared plus 3x cubed plus minus 75x. Okay, this is way too complicated. You would have to do the same thing with the bottom. Parentheses here, and you actually FOIL that out. So it would be x to the 4th minus 9x cubed minus x, okay, plus 105x. This is a little bit too complicated, and turns out this is not what they want you to do. So let's erase this, all of this stuff. That is not what they want you to do. What they want you to do, and they have designed these problems perfectly for you because you can factor them first, and then you don't have to FOIL them out. So for example, let's take a closer look at this first fraction. The numerator is x squared minus 25. Now, you can FOIL that out, or I mean factor it out, right? So to factor it out, it would be x minus 5, x plus 5, okay? And then the bottom part, or the denominator, would be, what happens if you simplify this? X squared minus 7x. So to simplify that, you can take an x out, and then you would have x and x minus 7. Easy peasy, right? Okay, now let's look at this one. This is the second ratio that they want you to consider and multiply it by. So here, I'm just going to put like a dot for times. And then how would we simplify this top one? Well, you can take out an x, right? So it's going to be x and then x plus 3, okay? And then the denominator is going to be this guy. Look here. I hope you're not doing this on your phone, because this would be super hard to see. Do this lesson on your iPad. Try and do it on your iPad, because you need to see all these tiny little numbers, and this gets really complicated. So how would we factor this one out? Since you're really good at it, I'll just let you figure it out, but the answer would be x squared minus x minus 2. Okay. No, I'm sorry, that's not right. It would be, I'm copying the wrong thing. You're probably like, what? Where'd you get that, Mom? Okay, the answer on the bottom would be x plus 3 and x minus 5. Okay, all right, sweet. Now these are all products. Since they all have parentheses around them, when you multiply these together like that, you don't need to FOIL anything out, because this is what's going to happen. This is the advantage. This is why these are specifically designed for you. Anything that is the same on the top and the bottom, you can just cancel it out. For example, x minus 5, that cancels out with this x minus 5. Okay, this x cancels out with this x. Okay, this x plus 3 and this x plus 3, that cancels out. So what are we left with? We're left with this over this. So the answer is x plus 5 for the numerator and x minus 7 for the denominator. Look at it, sweet, super satisfying, right? When you cancel all of that out. All right, that's the answer. That's it. Easy peasy. Let's do another one, because I know you're super happy now and you're ready to jump into another example because you want to do one of those satisfying problems for yourself. Don't worry, you will get the chance. But let's do another example just to show you this super complicated thing. Now, if you were to multiply this out, of course, you would have to put parentheses around this, and that would get way too complicated for our purposes. It's not even like it's not even FOIL. It's not even first, outside, inside, last, because there are like 3 terms, right? So you'd have to multiply this by every single term, and this by every single term, and this by, that's going to be horrible. So we're going to factor them out. So let's first look at this one. How would you factor that numerator out? And it's going to end up being x plus 3 and x minus 2. Okay, this is where that factoring comes in handy. You have to turn this into this. Okay, now I'm going to write a big long fraction, because this is all just going to get multiplied together. So in fact, we could jump ahead and do this other numerator if you want to. So the other numerator is x squared minus 8x plus 7 factored out. So if we do that, we've got an x, a 7, and an x and a 1. And it's going to be x minus 7, x minus 1. Okay? Now let's do those denominators. We've got this denominator, x squared minus 4x minus 21. How do we factor that? We get x minus 7, x plus 3. And then this denominator is going to factor out to x minus 2 and x plus 1. Okay, now we get our red pen out and we can start crossing things out that are the same. X plus 3 cancels out with this x plus 3. X minus 2 cancels out with this x minus 2. X minus 7 cancels out with this one. And you can see how these are perfectly designed just for the algebra student like you. We end up with x minus 1 on top, x plus 1 on the bottom. Sweet, that's the answer. Another super satisfying problem. All right, we're going to jump ahead to quotients of rational expressions. This is where you are dividing instead of multiplying. And remember, when you divide fractions, you have to flip the second one upside down. See, that's why I put that little GIF there for you. He's flipping it upside down, but it's his head, and that looks a little freaky. Okay, so for example, if you have a over b divided by another fraction, c over d, there you're saying you basically use the Dinesquire rule. Don't you remember that Dinesquire rule? Which is basically the denominator, numerator, same quantity rule. Same quantity rule. So that means if you multiply the bottom of this times d over c and the top of it by d over c, you're not changing the value of anything because you're multiplying the top and the bottom by the same fraction, which is basically multiplying it by a big number 1. So if you do that, then these cancel out and you end up with a over b times d over c. But you don't have to remember all of that. All you have to do is think. And when you've got a over b divided by c over d, what you can do is change this division problem into a multiplication problem. And to do that, you switch the numerator and the denominator, and you change the divide into a multiply. So you end up with a over b times d over c. That's the same thing that you got with the Dinesquire rule, but just remember that whenever you're doing division with fractions, you flip that second fraction around and change it to multiplication. So then when you do that, what do you get? You just multiply straight across. So it's going to be AD over BC. Sweet, right? Let's do an example. I know you're super excited, just like SpongeBob right there. Okay, so this, notice first of all, it's a division sign. So what we need to do is we need to change that to a multiplication sign and flip the numerator and the denominator. So I'm just going to do that straight ahead. X squared plus 5, I'm going to grab that. I'm going to put it underneath. I'm going to grab this. I'm going to put it for the numerator. Okay, see what I'm doing here? And then I have to change that to a multiplication. And now it's just the same thing that we were doing before. So once again, it's easy peasy. We're going to factor things out and see what cancels, okay? So let's factor this one out. X squared minus 2x. Let's just grab an x out of there. And then you've got x minus 2. Okay. And then let's do this denominator right here. We're going to have to factor that. X squared plus 2x minus 8. And that factors out to x plus 4 and x minus 2, right? X plus 4, x minus 2. Okay, now we're just going to multiply by that second fraction. So let's take this numerator and we're going to have to factor that out. And when you do that, x squared plus 7x is going to be x plus 4 and x plus 3. X plus 4. Don't worry if this takes you longer than it takes me because I'm just reading it out of the book. You actually have to do all the hard work. And then this bottom denominator here, it looks like I can just grab an x out of that. X plus 5. Okay, so then let's get out the red pen and start canceling because these problems were designed just for you. This x can cancel with this x. X minus 2, x minus 2. What else? Anything else? X plus 4, x plus 4. And then we're left with this over this. So the answer is going to be x plus 3 over x plus 5. Sweet! Super satisfying, right? That's awesome. You've got this now. You're feeling confident. Let's do one more example, 93.4. Don't skip ahead. Remember, these examples get a little bit more complicated every single time. So let's look. This is another division problem. So here we see a division. So first thing I'm going to do is get rid of that because I don't like division. I like multiplication. It's easier. So now we've got to switch the numerator and the denominator. I guess I'll do this. Okay, grab this, put it on the bottom. Grab this, put it on the top. Sweet. Now I've got a multiplication problem, and this is way easier because I can just multiply straight across. This times this over this times this. So let's see if we can factor and make it easier. Let's do purple. Why not? Let's do purple. Okay, so the top is x squared minus x minus 6. So this is going to be x minus 3. I know you can do these in your head, so I'm just going to write them down. But if you have any problems factoring or any questions about factoring, just let me know. Okay, so now I've got to do this one. X squared, oh, all my reminders are popping up. Sorry about that. X squared minus 3x minus 10, we're going to factor that, and we're going to get x minus 5 and x plus 2. I know I'm on the right track because I see things that are going to cancel already. Now, this second one, we're going to work on this numerator, x squared minus x minus 20. What does that factor out to? It factors to x minus 5 and x plus 4. And on the denominator, we're going to factor this guy out, x squared plus 5x plus 4, and that's going to be x plus 4 and x plus 1. Alrighty, time to get out that red pen, see what can cancel. Well, this can cancel. X minus 5 cancels. X plus 4 cancels. And then I'm left with this and this. And since we multiplied straight across, the answer is going to be x minus 3 on top and x plus 1 on the bottom. I love canceling, don't you? It's super fun. And guess what? This is the end of the lesson. So, bye, son. Bye, son. There's a bison for you to look at. Okay. Love you, Zach. Have a great day. Have fun doing your math. Okay. Bye.